everyone! Today our topic is waves. Okay, so let's start. What is a wave? A rhythmic disturbance that transports energy without transporting matter is called a wave. Now let's look at the types. Transverse waves, longitudinal waves, electromagnetic waves and mechanical waves, and etc. Now let's look at mechanical waves. Waves that require material medium for their propagation, like sound. Now let's look at electromagnetic waves. Waves that do not require material medium for their propagation. Here is a diagram that will show you. There is light but no sound from the sun to earth. Now let's look at transverse waves. Waves in which particles of a medium vibrate perpendicular to the direction of propagation of waves. Here are the examples of transverse waves. Waves in a guitar string, love waves in earthquake. Now let's look at longitudinal waves. Waves in which particles of a medium vibrate parallel to the direction of propagation of waves. Now let's look at examples of longitudinal waves. Sound waves in air, vibrations in gas molecules, P waves in earthquakes. So this is transverse waves and their example. Longitudinal waves and their example. It's simple to remember. Transverse waves are perpendicular and longitudinal waves are parallel. The topic is water waves. Okay, so let's start. What is a wave? Waves are one of the ways in which energy may be transferred between stores. Waves can be described as oscillations or vibrations about a rest position. Water waves are transverse. Waves traveling across the ocean are transverse waves. A transverse wave has undulations, which means having ups and down movements. These movements are at right angles to the direction the wave is traveling to. Here is a chart. So, here is the right angle and here is the wave. So, there are undulations, which means up and down movements. Here, up and down. Here is the right angle. This is the direction the wave is going in. And the energy is also going there. Waves transfer energy from one place to another, so it's putting energy from here to there. Transverse waves have crests and troughs. Here is a wave chart to show the crests and the troughs of a wave. So, the crest is the highest part of a wave, right at the top. The trough is the lowest part of the wave. When two crests join together briefly to make a bigger crest, like this example. So they both are going in different directions. They're going both towards each other. That will make a bigger crest. When two troughs meet, they join to make a bigger trough. So, they are both going towards each other. And when that happens, that makes a bigger trough. So, the wave chart shows us the top of the point and the lowest part of the point. So, the top one is a crest, the low one is a trough. And when two crests meet, when they're going towards each other, that makes a bigger crest. And when two troughs meet that are going towards each other, that makes a bigger trough. Now, the next topic is light waves. What is light? Light is a wave of energy, and it is a wave, like a water wave. Light waves are very similar to water waves. Here is the water wave, here is the light wave. You can see they're both in waves. They both are traveling like a wave with undulations, which means ups and down movements. There is only one big difference between them. It is that water needs particles to travel and light doesn't. Light waves travel fastest in a vacuum. Light travels faster when there are fewer particles to get in the way. A vacuum is when there is nothing at all. No air, no particles, nothing. The speed of light in a vacuum is 300 million m/s. Please like, share and subscribe. Thank you. Bye.